Good afternoon, everyone, and thank you for joining us for another edition of Talking Tech with SanDirect. My name is Robert Lennon. I'm the president and CEO of SanDirect, and we host these tech talks every 2 to 4 weeks. We try to focus on new products, technologies, and industry trends, and pain points in the industry, items and issues that's endearing to you and that you guys out there in the industry are looking to get answers for. So with that, we're very excited to bring in Kaminario, Wade Zilke, Regional Sales Manager with Kaminario, and Travis Lutz, our sales engineer, to talk about Flash and debunking the myths and theories, the myths of Flash and all the unknowns around it. It's a very hot topic in the industry. Applications are getting faster, and people need that speed and IOPS to go along with their storage. So we're excited to have Wade here today. With that, SanDirect, we are a storage-focused company. We've been in business for about 23 years now. We've always focused on storage. We're always looking for the latest and greatest industry in the industry and trends and technology. So that's why we brought in Kaminario to partner with us on this talk today. So with that, Wade, good to see you.
Good to see you, Robert. Thanks for having us.
Over to you.
Yeah, hopefully everybody's got their pizza by now, and
that's right.
We'll kind of jump right into this. So, as Robert had mentioned, there's a lot going on in the industry right now, and what we wanted to do is just review a little bit of some of the different solutions or types of Flash that are out there. We want to talk a little bit about how those designs differ, because there are wildly differing architectures available to you right now. We want to also talk about some of the facts and some of the things that are going on. You're going to hear all types of terms like effective capacity, and what do those type of things mean directly to you. We'll talk a little bit about Kaminario, exactly how our design differs from most everything else out there, and then we've got some good questions that we'll go over at the end of it as well. So I've been in storage a long time, and I think this is probably one of the most drastic changes or radical changes I've seen from just storage in general in a long time. And everybody's trying to jump on that bandwagon to be the next great large tier 1 type of storage company. Right now, there's over 500 different companies working on some type of flash storage product. And whether that is just a software-based approach, whether that is an all-flash array like Kaminario offers, or whether it's kind of something of both, there's a lot of people in the market right now today. The biggest thing I've seen, and one of the biggest drastic differences, is how much marketing hype is out there. You're hearing wild promises of what Flash can do, and hopefully we're going to go through and answer some of those questions and kind of level set the marketplace. The thing that I have seen, and I've been with Kaminario just a little over 2 years now, we thought it was going to be a much slower kind of adoption into the marketplace. When we first started shipping product, or when I first started with the company, I should say, it was very application specific we were seeing the Flash used for. Maybe we had a big database that we needed to perform better, so we're going to buy Flash for that. Well, now all of a sudden, in the last 8 to 9 months, we've seen it widely adopted for general purpose. People are completely getting rid of any of their spinning disk and putting Flash in specifically to run pretty much all of their major kind of tier 1 applications that are out there. It's interesting, Flash has really been the slow adopter into the data center. If you take a look at over the last 10 or 15 years how some of the other technologies have changed, I know my slide got cut off a little bit here, but over on the end, it's been the slowest adoption or change of technology from in the storage market, from spinning disk over to Flash. And now here we are in the last 2 to 3 years having really made quantum leaps in the ability to catch up with how fast the processors have gotten and the memory has gotten and the network has gotten and everything else. I know you'll always be chasing a bottleneck, but Flash has kind of at least eliminated the bottleneck on the back end from the storage device perspective. In order to kind of explain or to prove what we've been seeing, what we've been looking at, we did a very, very large study at Kaminario a couple years ago, and we interviewed hundreds and hundreds, if not thousands, of different people and customers out there. And one of the things that we found out is that 9 out of the 10 applications that are out there, the issue has been around storage-related problems. So whether, again, that's a database running slow or the latency's creeped up or whatever it is, we found out that the problems with performance were around the storage. But the thing is, what I think a lot of the companies that are doing, a lot of the vendors that are doing right now, is they're focusing so much on IOPS. I always kid when we're in our meetings and stuff that, you know, a lot of these companies have become the Dr. Evil of IOPS, right? I can do 1 billion IOPS, except that's not what it's about, right? There's really 3 major performance metrics that you have to take a look at. IOPS are obviously important, but I think more importantly in a lot of environments is you have to take a look at the throughput, you know, how much can I get into the system and out of the system at any time, as well as what's my latency doing. And I mentioned latency before. Travis and I probably talk more about latency and throughput than we ever do about IOPS when we're talking to customers out there. So, you know, it's really 3 measurements of performance around Flash. And then the other thing is we're seeing a lot of kind of mixed solutions out there. We'll call them hybrids. I'll get into it a little bit more as well. But I had a CEO say to me not too long ago, I should say CFO, he was looking at a hybrid solution which has some flash in it, has some hard disk out there. And he said, Wade, you know, if I go with a hybrid system, what I'm really doing is just kind of prolonging what I'm going to have to do anyways. Because he didn't really want to be stuck with spinning disk for another 3 to 5 years, which is what their storage refresh cycle is. So we're really seeing, again, the adoption of all-flash very, very quickly here in the industry. All right, let's talk a little bit about the different designs that are out there because there are several that I think are important. The first one is, you know, retrofitting an existing array. So maybe I've got some big spinning disk array and I've got a bunch of shelves on there, and what you're seeing is a lot of the vendors saying, you know what, just buy a shelf of flash and that's going to solve your ills. We'll talk in a little more in depth about that in a second. The second one is server side, and what I mean by that is really kind of the PCIe cards. I take them and I drop them into a server, and I'm kind of fixing that server, the application that's running on that server. And that's been very, very popular, and I have to give a lot of credit to the PCIe guys because this is really where flash adoption started taking off. The second one is, or the third one is hybrid. I'd mentioned hybrid a little bit ago. And then the fourth one is really Kaminario, and where you're seeing the big push and some of the real growth companies coming from is the all-flash side of it. So retrofitting an existing array is a little like taking a jet engine and putting it on top of a car that's 10, 20, or 30 years old, right? It's going to make that car really, really fast, but if I got to take a turn or something in that car, it's probably not going to get the best performance out of it. And that's exactly what we're seeing happen, or what our customers are telling us is happening as they're retrofitting older arrays, spinning disk arrays with flash. What happens is they're putting that flash in, and while it's giving them maybe, you know, a 7, 8, 9, 10x type of performance, flash should really be giving you a 70 to 80, if not more times of performance improvement over it as well. The other thing that happens is as you try to kind of bolt on some of the capabilities, and I'm talking about technologies such as data deduplication or some of the other ones, it's very hard to put that on and retrofit an old existing array. And the reason is you think about the algorithms that are writing a spinning disk versus how it writes the flash. It's a totally different way to do it. And that's, again, one of the reasons why you don't see as high performance out of a mixed environment or a retrofitted environment, and you're really not able to bolt on some of those capabilities. Those type of capabilities have to be designed from the ground up at the very beginning of that product, and you know, when the engineers started laying out the roadmap for a product. Now hybrids, you know, hybrids have a lot of promise, and quite frankly, I really like the hybrid solution, but I like it for very specific applications. And I'll give you one. I think VDI is a great application for hybrid, right? Because what I want to do is I want to avoid the boot storm. And so I've got, you know, kind of that boot storm and all that performance coming off the flash disks. I really don't need a lot of kind of performance out of the flash after that. Once all the virtual desktops are up and running, it's pretty much running great. But what I've seen out of those type of systems that have the hybrid type of systems where they're not just purpose built is you start to get into issues later on when you start doing it as more of a general purpose or a mixed environment for it. The other thing that's nice about hybrids is they're feature rich, right? You pretty much get every feature that you're going to get in some type of enterprise system in a very compact, pretty much inexpensive, what I would say, or low cost solution out there. The only thing that can go wrong potentially is, as I started saying, mixed workload environments, as that flash starts filling up, and really what it acts as is a cache in the system. So you have a lot of writes and everything going on in the cache, and then it gets moved down to your regular spinning disk tier. The issue happens is what happens when that flash starts getting filled up? Well, I've got a couple of partners that we work with who have said, you know, most of those hybrid systems that they have sold have had to add into that flash cache within the first 12 months. And that can be an expensive proposition. And what happens when that flash cache gets filled up is now the data essentially is going to try to get written directly to the spinning disk. but it's got to go through that flash tier first, and then it's got to get down to the spinning disk. And what happens is it would have been faster if I just eliminated that flash cache in the first place and started writing the spinning disk. So you have to be aware of how much and how that flash on those hybrid systems is going to fill up. And that's really going to happen in a mixed workload environment. As I said, for a specific designed application, I think they're great solutions, and I would absolutely take a look at them. For general purpose workloads, if I'm doing database and VMware and everything else, I would really take a close look on what's going to happen. All right, so today what we're seeing now is the all-flash arrays out there, and we're seeing really kind of, I don't want to call it revolutionary, but evolutionary designs that are out there. I'm going to talk a little bit about scale up and scale out. And I'm assuming everybody understands what scale up and scale out is, but I'll level set here in a second. And most of these newer designs can really use commercial off-the-shelf type of hardware. We don't need to have proprietary type of hardware or very expensive hardware in order to get these systems run. And so, it's helping drive the cost down very quickly and the adoption of flash very, very quickly. So let's talk about a scale-up type of approach. And I've always used the train analogy for the scale-up approach. So think of scale-up as a very legacy or traditional approach where I've got a couple of controllers and I buy these big honking controllers, right? Think of it like buying a giant engine for a freight train. And what I'm going to do below those controllers is I'm just going to keep adding storage and storage and storage until those controllers can't really perform anymore. It starts the bottlenecking. And so I compare it to what happens on a freight train when I just keep adding cars and cars and cars and cars. At some time, that freight train can't pull any more cars out there. So what do I have to do? Well, I either have to get a much bigger engine on there or start bolting engines together. And that can be a very difficult proposition. Most storage guys that I know have had to go through some type of rip and replace in their environment, and it can be very painful and very costly. Even today, with a lot of the NDU or the kind of upgrades on the fly, it can still be a bit of a harrowing experience to replace controllers when I'm taking one offline, bringing a new one in, and then replacing the second one and so forth. There's a lot of things that can go wrong, and we've seen that in practicality out there. The second one is scale out. And again, I'm a Chicago guy, so I always talk about the elevated in Chicago. It's more of a metro type of train, where each one of those individual cars, in this case the L platform here, if you've been to Chicago, each can pull about 100 and 150 passengers or so. And so what I want to do to bring more passengers, I just keep bringing more and more cars on. And so the train, keeps continuing performance. Performance stays great, no matter how many passengers I add. But at some point, I want to just add more passengers. I don't necessarily want to add more cars. It just gets too big. And on a scale-out design for storage, what happens is I keep adding in controllers of those 1U servers or 2U servers, however big they are, and I just keep adding and adding and adding. And the system gets really, really fast. But sometimes I just want to add more capacity, and I can't do that with a lot of those strictly scale-out designs. We saw a lot of the iSCSI designs 8-10 years ago or stuff when VMware was really looking for shared type of storage become popular. But again, what happened with those is I kept sticking in servers and servers and servers, and it got to be a very not only large footprint within the data center, but from a maintenance perspective, it became very costly as well, because it's a heck of a lot more costly to have maintenance on every one of those essentially servers than it is just to have it on some on the storage portion of it. So the thing is, though, let's kind of compare and contrast what's good and bad about those. So from a scale perspective, one of the drawbacks to scale up is it will never be faster than the first day you get about it. So think about it. When I put that scale up architecture in, as soon as I start adding on data, it starts slowing down because it's processing more and more and more every single day. I'm not adding any performance into it whatsoever. So again, at 20 to 30%, all of the flash arrays are going to really be burning. You got to start taking a look at what happens when I get to 50, 60, 70, 80% or more capacity, because you can fill up flash arrays from a perspective. I don't have to have a lot of reserve capacity the way I did with spinning disk. So now I can start literally thinking about, hey, I can go to 90% capacity on my systems. The second thing is, with those scale-ups, if I do want to expand, right, and more performance, what I start doing is I start creating bottlenecks or silos or islands of storage. And now instead of managing essentially one storage platform, I'm now managing multiple islands of that storage. And from an administrative standpoint, that can get to be a headache as well. And And then finally, really what you've seen from a scale-out architecture, it's a legacy architecture, as I mentioned before. It looks a lot like the spinning disk systems of the last 15 to 20 years. And by taking that and really just substituting flash storage for the spinning disk storage, it's very hard to add capabilities and features on. Right? A lot of these systems, when they've added deduplication during their life cycle, have taken a third-party product, bolted it on, and it causes issues out there. Replication's been bolted on to be able to do it. And we're seeing higher failure rates and more issues with that type of capability out there. From a scale-out performance, it's great to, as I mentioned before, I can make this thing as fast as I want. Right? I can create the Ferrari from the Volkswagen Bug if I want to do that, but that's not always what I want to do. The capacities tend to be considerably more limited on the scale-out architecture as well. I can only get as much storage in there as I've got slots available in each one of those controllers or those servers. And then one of the nice things about the scale-out is it tends to be very consistent and predictable. I know that I'm adding in this capacity and performance in very measurable chunks into the system. But again, as I go back to, if I just want to add capacity, what do I do? So if I need both, there needs to be a new design architecture, right? If I want that freight train that can also carry passengers, that's something that's not being done a lot out there. So we'll talk a little bit more about how Kaminario has kind of overcome those towards the end of the presentation. Now, I'd mentioned a little bit about proprietary hardware out there. There are some systems that are still doing it, specifically designed around ASICs and some of those other technologies. But today's processors, you really don't need to add in ASICs anymore. The processors themselves have more than enough capability and enough speed on them to handle the stuff that the ASICs used to do. So why are companies still doing it? I don't know, you're going to have to ask them on that one. But then also, what happens is a lot of times they'll use proprietary hardware in order to overcome software deficiencies, right? If I've got a system that tends to be slow or needs to do some background processes, I may have to stick an SLC drive or something in it to make sure that it keeps up. Well, you shouldn't have to be doing those type of, again, proprietary designs in order to create a great flash solution these days. The other thing that we hear out there is, how do I do changes or updates on those proprietary systems? Well, they usually tend to be pretty finite, right? I can't scale it up or scale it out past a certain amount. And when I do it, it's generally going to take an outage. There's one system out there, one flash vendor that's got a little bit of a reputation for running very, very hot out there. So what you want to do is, you have to open the thing up. There's jokes about having to use oven mitts to replace some of the parts in it and stuff. And so what I want to do is I want to get this thing done so it's not going down because the temperature is dropping inside the system. And then the final thing is, when you do it, as I said, just know what you're getting into, and you'll hear me talk about let the buyer beware in later slides as well. Just make sure that everything that you're buying within an all-flash array is on a non-proprietary type of basis, and it's really commercial off-the-shelf type of hardware. All right, marketing. I love talking about the marketing aspect because I think there's so much fear, uncertainty, and doubt out there, or FUD as people like to hear about it, that let's talk about a couple of things that are going on and what we're hearing specifically out there. Now, the best thing you can do is really kind of do your homework on this. Understand what a lot of those terms are. I mentioned effective capacity earlier. Understand what effective capacity means to each of the vendors that are out there. Understand how effective capacity is measured and block sizes and those type of things. And I think as this market tends to mature, we're seeing a lot more educated buyers out there than we had, even 6 to 9 months ago. People are really understanding, how flash is affecting and really where the flash has the effect in the system, or how it's helping that storage keep it up. A lot of people think it's just the flash media itself that's making these systems faster, and that's not it. The flash media is actually able just to keep up with the processors and the controllers these days. So one of the big ones is effective capacity. And essentially what effective capacity refers to is the fact that I've got all these great technologies that I can incorporate today because of how the flash can keep up. So you hear about deduplication. I think everybody's fairly familiar with deduplication, compression, thin provisioning, and a host of others that companies are marketing. Well, the thing is, deduplication and compression, everything works really well on very specific data types. Right? It's got some effect on pretty much everything. But if your data is coming in and it's mostly database, I can tell you you're going to get, you know, a 1-to-1 type of deduplication, somewhere maybe up to 1-to-5, maybe a little more. Again, your results will vary. But that's certainly not a 6-to-1 or 8-to-1 that a lot of these companies are promising. So you've got to be careful with the types of data are on there. Now, if I'm doing a VDI environment, I'm going to get great deduplication rates, right? I'm going to get that 8-to-1, 9-to-1, 10-to-1, maybe even more than that, depending on how my desktop images are set up. So at some point, you got to kind of figure out and average it. So make sure that you ask your vendors and the people that you're talking to about it, yeah, how are you guys getting to this, and can we test my data to see what kind of data reduction ratios am I going to get? And then the other thing is you're seeing a lot of, amongst these capacity guarantees, there are vendors using some of the SSDs in the background and not being very, very effective with it. Even if you're just to take a look at something as simple as a RAID 6, right? RAID 6 uses only about 66% of the capacity of the SSDs. Other RAID technologies are reducing that even farther. So make sure you understand what in terms of, not to some degree the raw capacity of it. Make sure you understand the usable, and also make sure you're understanding what the effective capacity is and how that's going to be measured as well. And then the other thing is see if you can get them guaranteed, right? Any of the data reduction that these guys are talking about is make sure that you get something in writing saying, hey, this is the minimum amount of data that we're going to make sure that you can store on this system. Because that effective capacity, right, it's unicorns and rainbows, guys. I have no idea what's going to be out there, but if you go and you're asking for budget request on this stuff, and they're telling you you're going to get 50 terabyte on it, and you end up only getting 20 terabyte because it's mostly database, that's not going to look real good when you have to go back and ask to buy more capacity out there. All right. So one of the things, and give SanDirect, give Robert a call, give myself a call. We put together a real simple calculator out there. And what you can do is you can essentially just put in your different vendors out there. You can put in what your raw capacity is, and then you can model the different ratios that are out there. Now this is something simple. You guys can put this together yourself, but at least now you can get an idea of if this guy's telling me it's 6-to-1 and promising me this type of dollar per gig, and this guy's telling me it's 3-to-1, I'm getting this type of dollar per gig. Well, now what I can do is at least put them side by side and make sure that the two numbers are matching up. Because the guys that are promising, a 6-to-1 type of data reduction may be giving you a low price, but the other guys that are promising it may be way high just because of, again, the dollar amounts of the systems themselves. Again, if you guys want this calculator, we've got a couple of them put together. Just give us a call and we can get it over to you. Quality of service, this is an interesting one, and some of the vendors have integrated quality of service with the system. And I can see in specific environments where it may be very effective, especially if I'm doing multi-tenancy, some cloud-based type of storage for this stuff. But most companies aren't going to need that type of quality of service. Within a lot of the all-flash arrays, it's all the performance, all the time to all the applications, right? And when you're talking 250,000 IOPS and 3.2 gigabyte per second throughput, or for us, we can scale up and over 1 million IOPS per second, over 12 gigabyte per second. Do I need to worry about quality of service the way I did with spinning disk? Well, the answer most of the times is no. So is that important to you? Is that something you're willing to pay for? And kind of his last one, as I mentioned there, why should I limit that type of performance to any of the applications? There's really not a need to, right? If I can throw that many IOPS and throughput at my databases the same way I can throw it at my VDI, I should go ahead and do that. All right. So marketing, I think everybody has seen this picture at some point in their life, right? And you look at it and you say, boy, is this an old hag or is this a pretty woman that I take a look at? And my point about this is, why should you have to pick what I'm seeing or one or the other? I think everybody really wants to, be with the pretty girl as they go on, right? And it's the same thing with your storage. I want to buy the storage that's going to be the best, and I don't want to have to limit myself to looking at it from, do I have to worry about capacity in the future, or do I have to worry about performance in the future? Now, everybody's making promises out there, and I talked about the market a little bit easier. There are some great marketing machines today, and it's hard to differentiate out there. But everybody is telling you ours is the fastest, smallest, cheapest, biggest support model, all this type of stuff. But let the buyer beware, because there is some real behind the scenes type of stuff going on. When you're looking at these guys, and a lot of these all-flash arrays are startups, right? They've been in business 3, 4, 5, 10 years, something like that. So make sure you understand how is their support done, right? Where's that support coming from? You know, when you say that it's the fastest, what are you basing that on? What's the block size out there, right? Is that been tested? Who's tested that? You know, is that an independent? Or is that one of the guys in your lab telling us it's that fast? There's a lot of things I think you really have to be careful about as you analyze and go through the comparison of all these. And just make sure you're doing your homework. I can't emphasize that enough. All right, so here's some of the funny ones that we've heard out there, and I always like to go through these real quick, and usually these get a couple of laughs out there. But we've heard all types of things about, you know, what is an active-active controller, what's an active-passive controller. And so what we've heard, you know, people say, we have active-passive controllers. Well, your controller should be active-active. But what we hear the marketing people say is we're reserving half of our processing power for other processes in the system. All right. The other one is, we can't disable dedupe. You want to turn dedupe on for everything that's out there. And again, that doesn't make any sense at all to us. They'll tell you that performance is the same whether dedupe is on or it's off, and it's not true. It's obvious. You need to spend more cycles when you have to dedupe the data. And then to pull these two together, and this was my favorite, the array is going to disable dedupe anyways. Well, didn't you just tell me the performance is the same whether dedupe is on or off, and you have to catch up with it? So again, just be careful out there, and don't let anybody tell you that's something that's a bug or that's not a fully baked feature or fully baked feature on the system it's not a bug or anything. All right, just be careful. And then again, I'd mentioned SLC before. We've got some competitors who can't keep up with the ingest and the dedupe and everything, so they write their data out to SLC. And SLC is a very fast technology, but it also still tends to be kind of expensive out there. So it's helping raise the costs out there. They shouldn't have to do that at all, right? The system should be able, and the design should be able to keep up with the deduplication and everything else that's going on within the system without putting, again, not proprietary, but additional hardware into the controllers. Upgrades are always a good one, and any system that's worth its salt should really have non-disruptive anything. Whether it's a software upgrade or a capacity upgrade or performance upgrade, should be non-disruptive. But there are a couple systems out there that have, you know, and you've probably heard a lot of the press about them, that, well, when you do an upgrade, we're going to have to move all the data off and then move all the data back onto the system to do the upgrade. Not sure how they get away with calling that a non-disruptive upgrade, but they do. And then the other one, yeah, we've got integrated UPSs. Integrated UPSs, you know, why do you need that, right? Most people have the UPSs kind of pulled out of it, and, you know, they'll market around the fact that we keep the system up and it's much more effective for it. But, you know, you'd lose your data if you didn't have those in there, and you shouldn't have to have them in there. It should be protected by, you know, battery back cache and those type of things. All right, so let's talk a little bit about Kaminario and really why we're kind of on that hot streak. In case anybody hasn't seen, you know, we just raised another $68 million in funding. Our Q4 results were about 400% over a year before, and so we're kind of flying high right now. And I think the big reasons is really our approach to the market. We're a very conservative type of company, right? We guarantee the capacities. I talked a little bit about that earlier. And what I mean by guaranteed capacities is, yes, we have all those data reduction capabilities. So I've got deduplication and compression and you know, thin provisioning is a data reduction technology of sorts. But I don't know what your data set's going to be. So what we've done is we put a capacity guarantee in place that, you know, within each one of our shelves, there's a minimum amount of data that we guarantee you will be able to store on that shelf, or we'll give you a second shelf and free SSD to get you to that minimum capacity. I don't know anybody else that's going that far yet. I think some of them are guaranteeing deduplication and data reduction ratios, but I don't know anybody guaranteeing it and backing it with giving you free hardware on the system. The other thing is software quality. We started in 2008. We are really on our 5th generation of product. So this product has really matured over the years. We're not a Gen 1, we're not a Gen 2 type of product. Very mature code that we've got out there. The other thing is we're very transparent. We're very open and very forward with everything, whether that's on the performance or on the pricing. Our performance, we've submitted our arrays to the Storage Performance Council. If you're not familiar with Storage Performance Council, they're kind of an independent auditor of storage and how it performs. And everybody can, you know, submit their hardware and their arrays to And what they'll do is they test all of the arrays the same way, so everybody, you know, can see what the results are. So it's not somebody doing, you know, a 4K block test and somebody doing a 16K block test. It's tested all the same way. And for, you know, a long time we were the we held the SPC1 and the SPC2 records on it. SPC1 is in terms of IOPS, SPC2 is in terms of throughput. And what was interesting, and they actually note it in the reports, and we can get you links to it, or we can post them out on SanDirect's website. What was interesting is we achieved both of those benchmarks on the exact same array. We didn't tweak it for IOPS and then tweak it for throughput. We said, here, test them on both. We want you to see what we get. And we ended up with both of them, both of those milestones. And then the second thing, you'll see we're very upfront on pricing. We talk about price per gig. We want to help you get to the truth on it using tools like that calculator. We also want to make sure that our systems are going to perform in your environment. So we do free performance analysis for anybody, because sometimes people just don't know. They don't know, is there latency creeping up? Why is my database not performing very well? And we'll come in and we'll do this very simple analysis for you and give you a full report that's actually presentable, ready to go to a C type if you need to go out and ask for budget to get those applications to run faster. And then the other thing is, we were purpose-built to do mixed workloads, right? We're not a specific application designed. We're great when it comes to VDI and VMware and Oracle and SQL and anything else that you want to throw on it, and we'll eat it up no matter what it is. And I'll talk in a second about how we do that. So the difference, I talked about scale up and scale out before, right? And this is kind of a typical scale out approach where I've got a couple of nodes and I've got a shelf and then I can add more shelves into it. But if I wanted to scale out, how do I do that? Well, with us, it's as simple as bringing a second one of what we call a K block in, which is a logical unit that has a pair of controllers into the system. Now, a K block with 2 K nodes will generate about 250,000 IOPS, about 3.2 gigabyte per second throughput, and sub-millisecond latencies. If I've got, you know, if I've got a heavy OLTP workload or OLAP workload and I need more performance on it, well, I can just bring another K block into the system. We connect in the background. Our communication protocol is going to be InfiniBand, and then you can actually connect either via fiber channel or iSCSI. No gateways, nothing else in the middle, right? Our nodes ship with both fiber channel and iSCSI HVAs in them. And very soon we're going to be supporting both simultaneously, fiber channel and iSCSI at the same time. As I add K nodes in, I add additional connections in, so now all of my performance linearly scales. So I go from 250,000 IOPS up to 500,000 IOPS, from 3.2 gigabyte per second up to 6.4 gigabyte per second, all while keeping that latency very, very low. Now, what we do then, in order to kind of make sure that we're minimizing and keeping that latency low and making the system very, very fast, is we go ahead and we write those volumes across every SSD that's in the system, no matter what shelf or what K block they're on. So this minimizes the number of hops or anything we'll have to do to get to the data at any point. It also helps with our HA and high availability, because now I can lose any node or shelf or anything and still have access to the data. Now, I'm not, you know, this I said, right? This looks like a very scale-up approach, or scale-out approach that we had talked about earlier. So you're saying, wait, if that's enough performance and I just want to add capacity, what do I do? Well, within our system, we can do that. We can just add more shelves under each one of these K blocks if I have enough performance. And then what we do is automatically in the background, without any intervention, we go ahead and we restripe those volumes across all the SSDs that are available. So this gives us the ability to scale the system out and be very predictable in the amount of performance, or scale the system up within the exact same array by adding capacity. All right? And we can scale this out as far as we want to millions of IOPS, or we can scale this up as big as we want by adding enough shelves into it to get to the capacity. We're at the point where our controllers are so fast, we're actually going to be adding the ability to add in more and more shelves under each of the K blocks as well. So it's kind of the best of both worlds. We're not going to dictate by our architecture how you want to scale it. You're going to dictate to us how you want to scale it by what's happening in your environment. Now, I talked about capacity and performance, and I want to talk a little bit about that guaranteed capacity. On each one of our shelves, a 400 gig shelf, we have either 400 gig shelves or 800 gig shelves. We can actually mix and match those under the K blocks as I had showed. So I could have a shelf of 400 gig drives, I could have a shelf of 800 gig drives, and no matter what size the drive is, I'm going to write the volume across all of the SSDs that are available. We'll be introducing larger drives later this year, and even those I would be able to put in as a second shelf and go ahead and write the data across all the shelves. So we're somewhat future-proofing you on as the flash capacities grow as well. But with the guaranteed capacity, each one of those 400 gig shelves is going to give you about 22 terabyte of that guaranteed space, or in the 800 shelves, going to give you about 45 terabyte of guaranteed space at about 250,000 IOPS. My slide got cut off a little bit here, but it would show us the throughput numbers as well. And as I added in either K-blocks or shelves, what it's going to do is it's linearly going to scale up as I add those in. So I'm literally going to scale the 400 gig shelves from 22 terabyte of capacity up to about 45 to 67 up to 90. The 800 gig shelves, we're going to do that same type of scalability, and the IOPS and the throughput and everything would scale 250, 500, 750, a million IOPS. Right? So it's predictable. So as you're growing the system and as you're doing your storage planning, you're going to know exactly kind of what increments that you can put in here and not guess by, well, if I add a shelf of flash into it, how much faster is it going to make it? How much capacity am I going to get out of there? We're guaranteeing these numbers for you. I've talked a lot about data reduction and storage efficiency. One of the things that we do, and one of the patents that we have, is on K-RAID. What K-RAID does is allow me to be, within a shelf, utilize about 87.5% of the actual capacity that's in there. I mentioned earlier RAID 6 will only give me about 66%. That's important from a couple of reasons. Number one, drives my cost per gig down, right? But the second thing is it's going to give me a much better level of protection, RAID protection within the systems. And essentially what we have is a RAID tree within this K-RAID. We can get very deep into it, on a separate discussion. But just to kind of give you a highlight of it, what we do is we start with a couple of parity drives and a Q drive. In a typical RAID 6, I'd have 2 parity drives, 2 Q drives. But our patent lies around the fact that we can share that Q drive in the parity groups. So if I lose a drive, what we do is we default from this K-RAID down to a RAID 6. If I lost a second drive, we'd go from a RAID 6 down to a RAID 5. So it's this RAID tree structure, right? And what's nice about it is I can lose 2 drives simultaneously per shelf and still be up and running. Technically, I can use a third drive, and my data is at least still protected by a RAID 5. So a lot of our customer base, and again, we've been around for a long time and had very high performance, started with a lot of big financials and companies that needed not only insane performance, but needed these high levels of protection as well. And kind of this 3-disk failure has been very good for us. Now, deduplication. I think everybody's familiar with it. I'm not going to get into the details of it. But essentially, deduplication for most systems is always on. But anybody will tell you that SQL data is not going to dedupe at all against Oracle data, and it's not going to dedupe against VMware data or anything else. So our thought is, why should we try to dedupe all those different types of data against each other when they're not, some of them aren't good candidates for it? So what we've done is our design allows you to have dedupe selectable on a per volume basis. And what I mean is, if I've got a SQL database that's going to come in, I might not want to try to do that because I know it's not a good candidate for the technology. So we can take that and say, I don't want this volume to dedupe. It's going to be in a dedupe volume group, and I won't have to worry about it. Yet the VMware stuff, which is running in the exact same array, I can say, go ahead, let's dedupe that. And we'll get those high rates of deduplication on it. Now, why that's important is overall, as you look, again, as that system gets more and more full, as I get to that 70, 80, 90% of capacity, all these other systems that have deduplication on all the time, that performance is going to start to degrade because now I'm taking new data and trying to dedupe it against all the hash tables or the metadata that's out there against everything else that's been out there. And so that could be 20, 30, 40, 50 terabyte of data. So it's just common sense that the performance is going to degrade. And we've seen this in every bake-off that we've gone head-to-head on those. Whereas ours, since we're not trying to dedupe data that's not a good candidate for it, our performance stays much, much higher than those systems that have it inline and always on. Compression, it's a technology everybody's familiar with today. For us, it has a negligible effect on performance, so we've chosen to keep it on. So when I talk about those guaranteed capacities, what we're really talking about is what is my compression ratio going to be, or my compression amounts going to be on the data that's coming into us. So that's really where we can give you that guarantee. We can combine the two, obviously, and increase it over what our minimum guarantee is. And then thin provisioning, I think everybody's pretty familiar with thin provisioning is as well out there. So when it comes to the actual performance of the system, where we're seeing some systems kind of fall down as you get really, really big, is our system is really designed to scale to whatever size you want. I'm talking about enterprise type of environments, or start, in a very modest type of footprint as well, a 4U footprint with, 20 type of terabyte on it. The big thing is you'll hear a lot about variable block sizes out there, right? And we've got a technology, I think it's on one of my next slides, that goes into adaptive block sizing and why that's important and hard to write it out there. Most applications aren't writing in 4K block sizes, right? But yet that's what the storage system is breaking it down to. Wouldn't you want your storage system to kind of match what block sizes are coming from the applications? And we can do that. And we've also got, we also have one of the things that we do is we have a patent pending metadata handling around that deduplication and the way we write the data out onto the different arrays. So this is the adaptive block size that I was talking about. And if you take just kind of a typical legacy architecture, what happens is if a 16K block chunk comes in, what I have to do is I have to break that up into 4 4K block sizes in order to write it out onto the disk, right? And this could be flash disk potentially. It's most likely going to be spinning disk out there. But what happens is that adds more processing out there, right? It makes a lot more for my system to have to handle. And I hope I haven't locked up here. Oh, man. All right. Well, for some reason, we've locked up on this slide, but I'll go through it really quickly. So a 16K block chunk would have to be written in 4 4K block sizes out there. We'll go try it again. So it starts. There we go. So it'll chunk it out into 4 4K block sizes before it writes it out to disk. That's going to lock up. That's okay. I'll go through it. What happens with the Kaminario system is if a 16K block comes in, I don't have to chunk it up because we can write block sizes up to natively 128K out to that, which again reduces the amount of processing and the amount of metadata that we have to handle on the system. So if a 16K chunk came in like it here, we'd write it just straight out to the spinning disk. If a 128K chunk came in, we'd write it out just straight to the flash. I said spinning disk, sorry, out to the flash natively on the system. Again, it helps the performance and it really reduces our latency on the system as we go through. Again, this gets into a much higher level discussion that we can have with Travis at any point if anybody would be interested on a separate webinar. Oh, there it is. So I had mentioned earlier the ability on our system, we've got no single point of failure anywhere. We've got a video that's going to be coming out here shortly where we actually pulled 2 drives on 4 different shelves, and we've got our performance monitor there, and you don't even see the thing move. So the fact that, in this 4 shelf type of application or array that we had set up, we pull out 8 drives and it doesn't even buzz the system. It's a pretty impressive video out there. But everything is also hot swappable. Our SEs always joke about, our system is so easy. A sales guy can do into the hot swap of any of the components out there. And everything our system, we don't talk about this maybe enough, is everything is in an isolated fault domain. So that gives us very, very consistent performance out there. And that's one of the ways that we did it as well. All right, real quick application, and we're starting to wrap it up here. Clearwater Analytics is a customer of ours, been a customer for a couple of years. Their challenge is they had very high latency on their databases. Their throughput was essentially bottlenecked by the concurrency of the number of NICs that they had on the system out there. Their reporting and everything had very, very long load times, and the larger reports took just forever, essentially. What they ended up doing is they put in 3 of our K2 arrays out there into the production DR, and then they bought one for dev test also. Each of them had about 45 terabyte of effective capacity, which for us is a guaranteed effective capacity. The results were pretty impressive. 75% shorter load times on the reports. We were able to do it in a single application or a single array, single solution, rather than having multiple different vendors out there for each one of the reports that they were doing, and their satisfaction levels are through the roof. We've got not only a case study on them out on our website, but I think we've got a video testimonial on it as well. finally, real quick, and this will wrap it up here, the company itself, some of you may not be aware of us. We've been around since 2008. We're technically one of the old men on the block. Our headquarters is based just outside of Boston, Massachusetts in Newton. All of our R&D is actually out of Israel. Our 3 founders came from 3 of the top manufacturers. They came from EMC, NetApp, and IBM. And when they got together day one, they started coding and saying, hey, here's the roadmap we want to lay out for this product, and it's proving itself out. We are privately held. One of our biggest investors is Sequoia Capital. If you're familiar with them, they've backed some of the smaller tech companies like Oracle and Microsoft and Cisco and Facebook, so they definitely know what they're doing. They were one of the main guys in this, one of the main VCs in this last round of funding that we got. As I mentioned, we were founded in 2008, but we actually started shipping production product in 2010. If you took a look at the product that we had in 2010 and the product that we had today, from a hardware standpoint, it's very different. That's because the actual hardware technology has changed over those last 5 years. But if you take a look at the OS, it's basically the same operating system that we've had all along. And we keep redefining it and adding on as again, the flash technology continues to evolve. But the key is, you've been able, and our customers have been able to kind of stay with us through that entire transition time. And then our customers, we're not purpose-built. We have customers in all the different vertical markets out there and literally across the globe. So there's nothing, I don't want to say there's nothing we haven't seen, but we've seen a lot of what's going on out there. It can probably help just about any customer at this point. So, Robert, I've talked enough.
Yeah, but it was awesome. Very informative. Thank you very much. Not to put you on the spot, but one of the beauty of the registration process is we open up questions to the participants. And we got a lot of great questions. I heard you knock off a lot of them. We talked about pricing and efficiencies with Flash, longevity of Flash, things of that nature. So we're going to boil it down to a couple ones. So I'm going to put you on the spot for a few minutes on some of the big ones. So first off, well, the question was, when is Kaminario 3U all-flash array going to be available? But I believe they meant Kaminario, the 3D
3D,
all-flash
yeah, I think that's probably what they meant also. Yeah, so in case you aren't familiar with it, what 3D flash technology does is it allows you to write data kind of on a, almost on a 3-level plane within the actual cell memory itself. So I'm taking essentially and tripling the capacity that I can do within the cells. That is, you're seeing that integrated really more on the larger drives that are coming out. We'll be integrating those larger drives a little later this year, and it'll be part of our offering there as well.
Okay, great. Next one is, we touched on this a little bit, but we can go into some more detail. What is the expected lifespan of the current technology, and how does it continue to improve?
Yeah,
some of the evolution of the OS, but
yeah, we hear that quite a bit out there, right? People still have this idea in their head that flash fails at a very, very rapid rate. You know, I'd probably agree if I had a thumb drive or something, right? It's going to last me 6 months and probably die at that point.
If you don't lose it.
Yeah, right, exactly. Yeah, but that's not what we're talking about. It's a different, essentially, beast that we're using, right? We're using an enterprise-class MLC drive out there, right? Yep. And so what our manufacturers, and we use 2 primary manufacturers for the drives that we use. We use Samsung, and we use Smart Technologies, which is now owned by SanDisk. The manufacturers actually warranty those drives for 5 years, and really what they're warrantying is the controller that's on that thing. It's not so much the cell or the storage that goes bad on it. It tends to be that controller. So our manufacturers are actually have a 5-year warranty on it. Because of the way that we lay out the data, and this that I talked about that volume, how we stripe the volume across all of the SSDs that are out there, we've actually been able to extend that warranty from the manufacturer's 5 years out to a 7-year warranty on all of our drives. So you're seeing, again, as far as failure rates in the field, we've seen very, very few to date, right? And we expect that to kind of be the trend going forward.
That's very competitive against disk, realistically.
Absolutely, absolutely. Because the other thing that we're seeing, and as we have this discussion with the CFO types at our customers, right? The fact that I can take today's controllers and SSD, right, and be able to expand, and maybe I don't buy it for 2 or 3 years and I decide to buy another K block, right? But it's going to be different processors and different controllers, and probably, you know, the storage may be the same. For us, it doesn't matter, right? So I'm always going to be able to keep that initial investment, and what I buy new is just going to continue to do its piece, or, you know, row its oar in the boat. Exactly, exactly. Yep. So it doesn't matter up. So we're really eliminating that obsolescence. So now that 7-year warranty really starts playing a part, because most companies have a refresh cycle somewhere between 3 to 5 years on their storage. You know, some companies try to get a little more out of it, but generally that tends to be what it is. Well, now we're having those discussions because of the technology. Man, can I have my depreciation schedule, my refresh schedule out at 5 to 7 years rather than the older thing? And that's a big discussion for the CFOs.
Gotcha. Great. Next one is we talked a little bit about. Well, we just talked about the SSD drives. How are they actually holding up to the manufacturer's expectations? So they're warranting them for 5 years. Manufacturers are seeing that, obviously, you mentioned that.
Yeah, absolutely, and we're seeing more and more of the all-flash array guys again expanding what those warranties are going to be on it, and I foresee that continuing on in the future. Gotcha.
Okay, and then the last one is it's a great question, and it's a great one to close on. How is Kaminario keeping data on the system secure? What are security protocols?
Yeah, security, and we're seeing that in just about every request now, right? Encrypting the data maybe wasn't as big a deal a few years ago, but now with all the breaches and everything else that's going on, everybody wants security on it. Sure. All the drives that we use are encrypted drives, right? Now for us, you have the choice of turning encryption kind of on or off at the CLI level. So no matter if you decide to do that key management and do the encryption portion of it, the data is always going to be encrypted on the drives, no matter if you decide to use key management or not on it. The other thing, and what's coming ahead is, if I'm sending those drives back to Kaminario or Samsung or whoever it is to be, how do I know that my data is not going to be on there? Because it's not like a spinning disk where I can just wipe it clean. There's actually, the push out there is for a technology or a process called secure erase, right? We firmly back secure erase. You can do it on the systems, but it will cleanly wipe those SSDs of any of the data that was out there. We can actually provide a certificate of destruction on the drives as well to say that it's cleaned. Now, some companies are going to say, well, I want to black hole those drives anyways, and that's possible. I think everybody has some type of maintenance contract to do that. But customers don't have to worry about sending a drive back and being able to read data if they want to run the secure erase process.
Gotcha. Great. Well, on that's all we have. We covered a lot today. Thank you again. It was good seeing you. Thanks for coming in. Listen, everybody online, thank you very much for joining us. We really appreciate you tuning in. Watch out for these. Like I said, we do these every 2 to 4 weeks. We always are trying to hit something that is pertinent to the needs and issues that you have in the industry. So we're always trying to bring new and exciting information and do it in a format that's a little more inviting and engaging to you online. So thanks again for joining us. Remember, if you have any questions on Kaminario or any of the other storage products that we carry, you can call us at 866-463-3372, SanDirect. We have certified storage architects on the phones ready to answer any questions. And it's fitting that we end on security. We've actually just started a security line as well, so if you have any needs as it relates to securing your data, we're also certified in those lines as well that we carry. So thanks again for joining us. Have a great day, and hope you enjoyed the pizza. Have a good one.